Yeah. All right, and here we have 1.6. So this is function operations and composition of functions. And you should be able to perform operations with functions. And so the same way that you can combine different operations, like adding, subtracting, multiplying, dividing, you can also combine two different functions. All right, so we can either add them. When you add them, you are just adding the two functions, and that's what it would look like. Right here, f plus g of x equals f of x plus g of x. And if you see f minus g of x, that's the same as f of x minus g of x. And then f times g of x, so this one we are going to see a dot for the multiplication. Okay, so that's just f of x times g of x, and the quotient f divided by g of x is equal to f of x divided by g of x, and g of x, there's a little side note, g of x cannot equal 0 because we can't have a 0 in the denominator. All right, so we will see these, and we'll also be looking at their domains. So after, we're going to see if the domain changes for any of them, because sometimes it does. Okay, so let's put these in the notes. All right, there's an example. So let's look at some examples here. It says find f plus g of x, f minus g of x, f times g of x, f divided by g of x. For each f of x and g of x, state the domain of each new function. All right, that's quite a bit. So I'll do the biggest one there. Let's do 3. All right, and if you want to try number if you want to try one is pretty cool because it has that radical. All right. So try 1. We'll do number 3 here. So first thing I want to do is I want to find my f plus g of x. Right, and I'll color coordinate, I guess. The f of x is going to be red, and the g of x is going to be blue. All right, so here we're just adding the f of x, which is x squared plus 5x plus 6 plus, and our g of x is x plus 2. So you're just basically adding those two together. All right, you're probably thinking, what can we do next? Combine like terms. You want to simplify as much as possible. So we have 1x squared and nothing to combine it with. So we just have x squared. Here we have a 5x plus x. So 5x plus 1x is 6x. Or maybe I'll plus 6x. And then we have our constants. 6 plus 2 is going to give us 8. And there you go. That's it. That's all we can do. Now the domain is we want to look for any restrictions. Okay, so remember for domain, look for any variables in the denominator. If you have a variable in the denominator, you want to set the denominator equal to 0, and then solve. All right. And if you have a radical, you want to set the radicand equal to, sorry, greater than or equal to 0, and then solve. All right, so here we don't have any of that, so because of that, this is going to be, the domain is all real numbers. So all real numbers. So it means any number will work. All right, so there's that one. And now we're going to look at subtractions. F minus g of x. And there you want to do the same thing that we did with addition. With one little side note. So you have x squared plus 5x plus 6. That's our f of x. And then our g of x is x plus 2. And we have that minus sign in front. Whenever you have a minus sign in between, you want to put parentheses around that second function. Okay? Because we're not just taking the negative of the x, we're taking the negative of the whole function. Okay, we're not just subtracting the x only, we're subtracting the whole function. So there, after you do that, we want to distribute. So distribute that negative, we get negative x minus 2, basically just changing the signs. All right, and now we can combine like terms. That x squared is again by itself, so sad. We have that 5x minus 1x is going to give us 4x. And then 6 minus 2. That's probably what was going on, right? So that gives us 4. All right. And we don't have any x's in the denominator. We don't have any x's in the square root. So this one is all real numbers. The domain is all real numbers again. Today, of course, the already dry region filled with sand, rock, mountains. So because the climate change over the last 3,000 years ago. All right. So now let's look at the multiplication. So f times g of x. So over the this one you can write it however you like. You can do it vertical or horizontal method, whichever way you like is fine. For me, I like just distributing. So I like to, and you need to put parentheses for these. So x squared plus 5x plus 6 and times the quantity of x plus 2. All right. So remember when you are multiplying two expressions, two functions, or two expressions, okay, you have one expression and the second expression. What you want to do is you want to do FOIL, but here we have more than FOIL, okay? So you want to multiply each of these terms by each of these terms. So you're just distributing each of these to each of the terms in the blue function. So x squared times x and x squared times 2. we get x squared times x is going to give us x cubed plus, and then x squared times 2 is 2x squared. All right, we have that. In hindsight, I should have moved this down a little bit, so that's what I'm going to do. Let's move it down. Moving on down. There we go. All right. And now we're going to multiply this 5x by everything. So 5 times x is 5x times x is 5x squared. Remember, when you multiply variables, the same variable, you just add their exponents. So 1 plus 1 is 2. Over here we had 2 plus 1. That's how we got that 3. I forgot to mention that earlier. All right, and then 5x times 2 is going to give us 10x. 5 times 2 is 10x. And almost done. Last one, going to multiply 6 times x, and then 6 times 2. So we get 6x. 6 times 2 is 12. And then we combine like terms. So x cubed and 2x. Way to learn about that was the discovery of fossils and bone, right? And there's technology and science that goes 2x squared plus 5x squared is going to give us 7x squared. Then you have 10x plus 6x is 16x. Then we have 12. Scientists called archaeologists interpret artifacts. These scientists piece together evidence, tell the story of what happened at a site. So based on the discoveries, there we go. And again, no x's in the denominator and no radicals. No x's in the radicals. So the domain again is all real numbers. All right, and the last one, division, f divided by g of x. That's just one technique. So we have x squared plus 5x plus 6 divided by x plus 2. Now here we can either have, when you're dividing, it could be either really simple, like we could be done, and boom, you're done, or it could be a little bit more work. So it depends on those polynomials. So this one up here, our numerator, notice that it's quadratic. Okay, it's x squared plus 5x plus 6. So here we want to see, can we factor? Factor. All right, so remember to factor, you want to do factors of a times c. That adds up to b. So what times what will give us 6? So what are the factors of 6? That will add up to 5. 2 plus 3. So here we get x plus 2 and x plus 3. Now here, because after factoring, we want to say, hey, is there anything that can cancel out? Is there anything that's on the top that's also on the bottom? And remember, if you don't see parentheses, there's actually invisible parentheses around the x minus 2. So anything that we have on the top that we also have on the bottom? Yes, the x. Oh, sorry, that should be a plus 2. Yes, the x plus 2. So this cancels out with this. And what are we left with? X plus 3. Do you have to leave the parentheses? You can, doesn't matter. Okay, you don't need to. And there, it's just x plus 3, so you would think, hey, it's the domain is all real numbers, right? However, we want to think about it from the very beginning. So dividing it, notice that we have that x in the denominator. Okay. So we have that x in the denominator. So what we're going to do is we're going to set that denominator equal to 0. Because we can't let the denominator equal 0. So we want to find out where it's equal to 0. What number of x will make this equal to 0? And then the domain is anything except for that number. So solve for x, you get x equals -2. The domain is all real numbers except for 2. Sorry, -2. So you can also write it like this. It goes from -infinity to -2, rounded parentheses, because it doesn't include the -2. Then union -2 to positive infinity. All right, and there you go. That's number 3. A lot of work for one problem, right? Yeah, that's why we just did one. Okay, so try number 1. And let's see, what time did I get out? The PD schedule today. $11:25. All right. Is there enough to do 8? Can we do 8 in 7 minutes? Yeah, I'll just do it all in black if that's okay. Again, still try number 1. So let's look at number 8 where we have uh, kind of fractions or rational numbers, rational functions. So here we go. The first one, f plus g of x. And whenever you have fractions and you're adding and subtracting, those are going to be a little bit more tricky. All right. So what we're doing is we want to get a common denominator. The way we get a common denominator is the way you learned it in elementary school. Multiply by the other denominator. So we have a 4 and we have an x. So I just like to multiply by the other denominator. Make it simple. You're going to multiply this by 4. Then we get x squared plus 12 over 4x. And then we have a 4x there, so it's the same denominator. And that's it. That's all we can do. All right, and the domain is 4x equals 0 So x equals 0. So you can say all real numbers where x does not equal 0. You can write like that also. Or if you want to write it in interval form, negative infinity to 0, and then 0 to positive infinity. You can also say that. All right. And then subtraction. So f minus g of x. We have x over 4 minus 3 over x. Again, same thing with subtraction and addition. You want a common denominator, so we multiply by the other denominator. So we have a 4 and an x again. Multiply the first one by x. Multiply the second one by 4. And you get x squared minus 12 over 4x. And that's it. So here, same thing, the domain. You want to do 4x equals 0, so you get x can't equal 0, so all real numbers where x doesn't equal 0. If you want to write negative infinity to 0, then union 0, comma, positive infinity, that's also okay. All right, and then the multiplication, this will be fun. We have 3 over, we have x over 4 times 3 over x. So here, fast way to do it is to cancel out cross-canceling. Whatever's on the top on one side and on the bottom, those can cancel out. All right. But if you don't feel comfortable doing that stuff, it's okay. No worries. You can just multiply across also. Okay. But you do want to get familiar with canceling things out diagonally. So here you can also multiply across. So 3 times x is 3x. 4 times x is 4x. And then notice that they both have x's. So now we can cancel out those x's like that. And we get 3 over 4. All right, and then the last one, f divided by g of x. We have x over 4 divided by 3 over x. Okay, so remember when you're dividing fractions, what you want to do, the first one stays the same, but then just multiply it by the reciprocal, so x over 3. So the reciprocal of this means you just flip it upside down. And there you go. So you have x times x is x squared, and 4 times 3 is 12. And that's it. That's all real numbers, the domain. All right, and that is it. Um, there's another way to look at dividing fractions. I'll probably mention this later. But yeah, you want to look at the two C's. So you have a big C and you have a little c. Okay, so x times x is going to give us x squared. And that's the big C goes on top. Little c goes on the bottom. 3 times 4 is 12. X times x, 4 times 3. All right, and that's it. That's another way to look about doing that. I'll put that on the notes. And that is it.